Hello to another problem solving session. So today we have a problem in one-dimensional constant acceleration motion. So this is a one-dimensional constant acceleration motion. Okay, so the motion can always be placed on the axes. So we like to place it, say, on x-axis, and is the origin. And always there are two time situations. So we call it, normally we should call this time zero is car is here, and it's always a good idea for a problem, the setting is to initial velocity be in this direction. So v0 in here is this 40 meter per second. So it's going in this direction, so final will be here. So t equals to final time is here. And according to the situation, the car is to stop, meaning at this point v is equal to 0. Sometimes we call it v sub f, but I'm not going to use too much notation. We're going to also just call it t here, not call it tf. And so there is a position here, is the initial position. So this called x0 is 0, and this is the final position. So final position, sometimes you call it xf, but I'm going to just call it is x. So let me lower the thickness of the pen. Okay, so these are the initial and final, and then in between what's going on is in between between here to here, what's going on is acceleration is constant. In this time frame, the acceleration is actually decelerating. So acceleration is pointing that way. Acceleration vector is pointing that way, and is 30 meter per second squared. So it's going to be, if this side is positive direction, then this side will be negative direction. So the acceleration, you can call it negative. So okay, so the formulas that you probably know that will be useful here is using these notations. Formula will be, one will be x equals to v0t plus half at square. Another formula would be v square equals to v0 square plus 2ax. Another formula will be x is the average velocity times t. And what is this? This will be v plus v0 over 2. Because acceleration is constant acceleration, average velocity is that. If the acceleration was not constant, if a is not constant, say acceleration dependent on time, where I'm here, then these will not be the case. So these not be the case. Okay. Okay, so let's do it. So let's see A. To solve A, of course, this kind of problem can be done many different ways. Solve A is I need to find the distance. So here is find x. Okay, you look at this, we know this, we know this, we know this. The sign is important here. So that's a very careful about sign. That's very, should be careful over here. So this would be immediately, so this is 0 equals to 40 square plus 2 times minus 30 x. So x will be, you can already see this minus, and when I bring this down the other side, there will be minus. This minus will cancel out, and so 40 times 40 over 2 times 30, and so this will be cancel out. This will be become 2, and so this will be 80 over 3 meter. So that's will be the answer for x. How about B? How much time does it take for it? So a couple of different, we can use the x we found, or we can just do it using this, or there's another equation would be v equals a v0 plus a times t. So here also here is a time, we can find this, from this we can find the time. So v is how much time does it take, and again here has to be careful with the sign. So if I use this one, then I have a 0 equals to v0 is 40 plus minus 30 times t. Then this becomes, that side minus cancels out, and so the t equals to 40 over 30 is 4 over 3 seconds. So these are the answers. You see, what if I had used this in here? Well, so the B can be done another way. I use 80 over 3, and I have a 40 plus 0 over 2 times t, and immediately it's the same answer. You could have used this equation, because you already know x. That clearly is much more complicated with doing it, because you're going to deal with the quadratic equation t. But the upshot is there are many different ways of doing this problem. One way would have been to do b first. Maybe do b first. So you get a t using this. So t is 4/3 second. Then a using this equation. So x equal to 40 times 4 over 3 plus half. A equals to, again sign is very important for a here, minus 30 4 over 3 square. And if you simplify, you should get the same answer. So this should be equal to 80 over 3 meter. Okay, that's it. We'll see you in another video. Bye.